Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be going over geometry, lessons 2-3 and 5-4 on deductive and indirect reasoning, as well as inverses and contrapositives. We have lots of vocabulary to get through today, so let's go ahead and get started with deductive reasoning. So remember that deductive reasoning is logical reasoning, and it's a process that goes from a statement to a conclusion. You have done deductive reasoning lots of times in science class. You come up with a hypothesis, you test the hypothesis, you come to a conclusion. So some examples are listed here as well. There are two laws that you use in deductive reasoning. The first is called the law of detachment. So the law of detachment says if P, then Q. And so if P is true, you can conclude that Q is also true. You'll find a good example of this on the lesson for this on Canvas. It says, if a student wants to go to college, then the student must study hard. So if P, then Q. And then Rashid wants to go to the University of North Carolina, so that's college. So we know that the P part is true. So we can conclude that the second half, the Q part, is also true. So the answer is that Rashid must study hard. And that is the law of detachment. The second law is the law of syllogism, and it says that if P, then Q, and then there's a second statement that starts with the same phrase, if Q, then R. And so what the conclusion is that you cut out the middleman there and you go from if P, then R. There's another example of this on Canvas under the lesson for this, and it says that if you read a good book, then you enjoy yourself. So that's if P, then Q. The next statement begins with the Q statement. If you enjoy yourself, then your time was well spent. So if Q, then R. So you can cut out the enjoy yourselves part. And the conclusion there is if you read a good book, then your time was well spent. And you can agree that that is a true statement according to the law of syllogism. All right, so we move on to lesson 5-4, and we're going to start with negation. So negation is a statement with the opposite meaning and the opposite truth value. So the statement here would be Albany is the capital of New York. The negation is the opposite of that. So Albany is not the capital of New York. You will frequently see the word not in negation. You'll find some of these in the lesson as well. For example, the statement is you are not 16 years old. The negation of that is the opposite. So you are 16 years old. Or the soccer game is on Friday. The negation would be the soccer game is not on Friday. So again, with symbols in geometry, how you would write this, whatever your statement might be, we might call that statement P. For it to be the negation of P, you put a little kind of like an NEA sign in front of the P, and that means not P. All right, we move on to inverse. So when you are doing an inverse of a conditional statement, it negates both the hypothesis and the conclusion. So the statement here, the hypothesis, if a person is mean. So you negate that part down here if a person is not mean. And the conclusion of the statement, then they are a fighter. You negate that. So then they are not a fighter. So the inverse keeps them in the same order but negates both sections, the hypothesis and the conclusion. So in geometry, you would write an inverse as not P. If not P, then not Q. And that's how you would write an inverse. Your practice has one of these. One of the questions says that the conditional statement is if an angle is a right angle, then it measures 90 degrees. And they want to know if the inverse is if an angle is not a right angle, then it does not measure 90 degrees. And that would be an accurate inverse. All right, so we move on to a contrapositive. And a contrapositive is a condition that is always linked to the inverse of a statement. And it always switches the hypothesis and conclusion, and it negates them both. So whatever the inverse is, you are going to switch those. So, for example, in the question we were just talking about, there's a conditional statement, an inverse, and then they ask you for the contrapositive. So our conditional statement, if an angle is a right angle, then it measures 90 degrees. The inverse of that negates both the hypothesis and the conclusion. If an angle is not a right angle, then it does not measure 90 degrees. The contrapositives keeps the negation but flips the hypothesis and the conclusion. So if an angle does not measure 90 degrees, then it is not a right angle. And in geometry, the way you would write a contrapositive is, if not Q, then not P. All right, so we have learned, of course, that conditional statements and their inverses can have different truth values. Contrapositives and their conditional statements always have the same truth value as the conditional. So anytime a statement has the same truth value, those are known as equivalent statements. And here is a little diagram to kind of remind you of what everything is. So we talked about conditional statements in the previous lesson. If P, then Q. The converse of that flips the hypothesis and the conclusion to be if Q, then P. And these three we talked about here. Inverses, if not P, then not Q. Contrapositives, if not Q, then not P. And we've also, of course, talked about biconditionals in the previous lesson. P, if and only if Q. And now the last part of today's lesson, indirect reasoning and indirect proof. So suppose your brother tells you, Susan called a few minutes ago. You think through these 3 steps. Step 1, you have 2 friends named Susan. Step 2, you know that one of them is at band practice. So step 3, you conclude that the other Susan must have been the caller. That's called indirect reasoning because you considered all the possibilities and proved them all but one false. So the remaining possibility must be the truth. So for an indirect proof, which is something that we're going to use here in geometry, we're going to do a lot of proofs. If you are doing a proof involving that indirect reasoning, it's called an indirect proof, and it has 3 important steps. They're listed below. Step 1, you always begin with the assumption of the opposite or negation of what you want to prove. Then you prove that this assumption leads to a contradiction and conclude that that assumption must be false, and what you want to prove must actually be true. The important thing to remember about this here is step 1. You always start with the opposite of what you want to prove. So good luck, everybody. I hope you guys all do great.